Chapter 2, Water in Equilibrium, Nature's Honest Witness. If you want to understand Earth's true geometry, observe water. Water has no agenda, no theory to defend, no presuppositions. It simply responds to gravity and settles into its lowest energy state. This is hydrostatic equilibrium, the condition where a fluid experiences no net force and remains at rest. Every human from ancient times to today has observed water's fundamental property. Water finds level and stays level. A glass of water sits with a horizontal surface. A lake appears level to the horizon. The ocean, as far as the eye can see, presents a level plane. The question is simple. What does level mean? According to the Standard Model, level means conforming to a curved equipotential surface. Water on a spherical Earth would follow the sphere's curvature, maintaining equal gravitational potential everywhere. According to direct observation and classical hydrostatics, level means horizontal, a plane perpendicular to gravity. These definitions are incompatible. Water cannot simultaneously be a plane and a curve. Let's examine what water actually does. The salt pan test. The Salar de Uyuni in Bolivia is Earth's largest salt pan, covering approximately 4,086 square miles. When rain falls, a thin layer of water covers the salt, creating what photographers call the world's largest mirror. The water settles into perfect levelness, creating flawless reflections of the sky. The salt pan extends roughly 31 miles in some directions. If Earth is spherical with radius 3,959 miles, geometry predicts a specific deviation from a horizontal plane. Using the Saad-Jitta formula for the height of an arc, S equals for a 31-mile span. S equals 961 31,672. S equals 0.0303 miles equals 160 feet equals 49 meters. This means there should be a 49-meter elevation difference between the center and edges of the salt pan, roughly the height of a 16-story building. When water floods the Salar de Uyuni, does it reveal this geometry? Does it pool at the edges, flowing away from the elevated center? Do measurements show a 49-meter bulge? No, the salt pan is level. Elevation measurements show variations of only a few feet across the entire expanse, not 49 meters. Water spreads evenly and remains level. How is this possible if Earth curves? The standard explanation, the standard response. The water is following Earth's curve. Your instruments follow the curve too, so you can't detect it. This explanation claims that level doesn't mean horizontal in the Euclidean sense. Instead, level means conforming to the geoid, an equipotential surface that curves with Earth. Water finds this curved level, and measuring instruments can't detect the curvature. This sounds sophisticated, but it has a critical flaw. It's unfalsifiable. If every instrument designed to measure levelness follows the curve, and therefore cannot detect it, then the curve can never be directly measured. We must accept it as an article of faith because theory demands it. But consider, if we can't measure the curve directly, why believe it exists? The claim rests entirely on theoretical commitment, not empirical observation. Establishing a reference, the fundamental question. How do you establish a horizontal reference plane over 31 miles? A laser beam travels in straight lines through uniform media. Yes, atmospheric refraction can bend it slightly, but over a clear day at ground level, the effect is measurable and correctable. Engineers use lasers precisely because they establish straight line references. If you aim a laser horizontally across the Salar de Uyuni, does it curve 49 meters to hit the far side? No. A horizontal laser would sail over the far edge if Earth truly curved that much over 31 miles. Water itself provides an even better test. Water in hydrostatic equilibrium forms a horizontal surface, a plane perpendicular to gravity. It doesn't know about geoids or equipotential surfaces. It responds to the actual gravitational force acting on it. If gravity pulls radially toward a center, a large body of water should show convex curvature when measured against a true horizontal reference. If gravity is uniform or parallel, water settles into a horizontal plane. The Salar de Uyuni shows the latter, a level plane, not a curved surface. In other salt pans, the Salar de Uyuni is not unique. Examining other salt pans worldwide reveals the same pattern. Bonneville Salt Flats, approximately 30,000 acres. Famous for land speed records precisely because it's so level. Elevation variation across the entire surface, less than 2 feet. Used for high-speed racing because the levelness is consistent and predictable. Tosha Pan, approximately 1,900 square miles. When flooded, water spreads evenly across the surface. Wildlife gathers around it because water pools uniformly rather than draining to hypothetical low points. Magadikadi Pan, over 3,000 square miles. Ancient lake bed, remarkably level surface across massive distances. In every case, these formations are level to within feet across dozens of miles. If Earth curves at 8 inches per mile squared, these places should show dramatic elevation changes. They don't. Large bodies of water consider Lake Superior approximately 350 miles long, covering over 31,000 square miles. If Earth curves, the lake's surface should show massive curvature. Using the Sagita formula for 350 miles, the water at the lake's center should be nearly 4 miles higher than the water at the ends, measured against a horizontal reference plane. Do ships crossing Lake Superior navigate a 4-mile water mountain? No, the lake surface is level. Vessels traverse it on what navigators treat as a horizontal plane. The standard explanation invokes the geoid again. The water curves with Earth. But if so, why don't engineers building structures on opposite shores account for massive elevation differences caused by this curvature? They don't because the surface is level. The Chicago skyline is visible from across Lake Michigan, approximately 60 miles away, from certain vantage points. According to spherical geometry, Chicago should be hidden behind 2,400 feet of curvature. Yet on clear days with appropriate atmospheric conditions, it's visible. The standard explanation, atmospheric refraction. But notice the pattern. Whenever observation contradicts prediction, an additional mechanism is invoked to explain it away. River basin geometry, river drainage basins present a geometric puzzle for the spherical model. Consider the Amazon basin, approximately 2.7 million square miles. It's called a basin because it's concave, shaped like a bowl. Water drains from elevated edges down into the central river system. But here's the problem. If Earth is spherical, how can a basin be concave over such distances? Visualize draping a bowl over a basketball. The bowl itself is concave, but once draped over the ball, the outer surface becomes convex, curving outward to follow the ball's surface. If Earth is spherical, the Amazon basin, extending thousands of miles, should be draped over that sphere. Relative to the surface, it might appear concave, but relative to a horizontal plane, it should show overall convex curvature. The center should bulge upward. Yet the Amazon basin functions as a genuinely concave depression. Water flows from high edges toward a low center and pools there. This is the behavior of a concave basin on a plane, not a convex surface on a sphere. The Mississippi Basin shows the same pattern. Tributaries from the Rockies, Appalachians, and Plains flow downward toward the Mississippi River. If this basin were draped over spherical Earth, the river itself should be hundreds of feet higher than the edges when measured from Earth's theoretical center. Yet water flows toward the river from all directions. The Congo Basin exhibits identical geometry. It's a depression. Water drains into it from surrounding highlands. Concave basins on a convex sphere present a geometric impossibility. They make perfect sense on a horizontal plane with uniform downward gravity. Take classical hydrostatics returned to basic principles. In classical fluid mechanics, hydrostatic equilibrium occurs when the pressure gradient in a fluid balances gravitational force. For a stationary fluid, this produces a horizontal surface, a plane perpendicular to gravity. This is precisely what we observe. Large bodies of water, lakes, seas, flooded salt pans settle into horizontal surfaces. Yes, waves and tides disturb these surfaces temporarily, but the equilibrium configuration is planar. The standard model claims these surfaces are curved, but that instruments following the curve cannot measure it. This removes the claim from the realm of empirical science into unfalsifiable theory. The parallel gravity model makes a testable prediction. Water settles into horizontal planes over large distances, showing no measurable curvature. This is exactly what observations reveal. Where is the 49-meter bulge? Return to the Salar d'Uyuni. 31 miles of salt pan. If spherical geometry applies, there should be a 49-meter elevation difference between center and edges. Surveyors have measured this formation extensively. The elevation variations are on the order of 1 to 3 feet across the entire pan. Not 160 feet, not even 16 feet. Where did the 49 meters go? The answer cannot be, it's there but unmeasurable. Either the surface deviates from horizontal by 49 meters, or it doesn't. This is geometry, not interpretation. Water in hydrostatic equilibrium on the Salar de Uyuni forms a level horizontal surface. Measurements confirm this. The simplest explanation, the surface is horizontal. Earth exhibits planar geometry. Gravity is uniform and parallel, not radial and convergent. Engineering confirmation, consider the Suez Canal, 120 miles connecting the Mediterranean Sea to the Red Sea. If Earth curves, the middle of the canal should be approximately 1,600 feet higher than the ends. The canal was constructed using standard leveling techniques, establishing a level water surface from end to end. No curvature corrections were applied. The water surface is level, connecting both seas at equal elevation. If the canal curved by 1,600 feet, water would flow from the elevated middle to the lower ends, creating catastrophic currents. This doesn't happen. The canal demonstrates that over 120 miles, water is level and Earth's geometry is planar. The standard response: the canal follows the geoid. But this is linguistic gymnastics. The surveyors used physical levels defining horizontal planes. The water surface is perpendicular to gravity. Call it what you will, the geometry is planar. What water reveals water is nature's most honest substance. It has no bias. It responds purely to gravitational force, settling into equilibrium. When we observe water across salt pans, in lakes, through canals, in drainage basins, we see level surfaces with no measurable curvature over vast distances, concave basin geometry, hydrostatic equilibrium on horizontal planes, behavior consistent with uniform, parallel gravity. Every observation supports the parallel gravity model on a planar surface. Every observation requires additional explanations and unfalsifiable claims in the spherical model, the epistemology of water. Here's a philosophical question. Should we trust what water shows us, or should we trust theoretical frameworks that contradict it? Water's behavior is direct observation. We can measure it, test it, verify it independently. Its behavior is consistent across all locations and scales. The claim that water curves is theoretical interpretation. It requires accepting that our instruments cannot detect what theory predicts. Science is supposed to be empirical, following observation. When observation consistently shows one thing and theory predicts another, which should we revise? The scientific answer: revise the theory to match observation. Implications: if water reveals planar geometry over all tested distances, several conclusions follow. 1. Gravity acts uniformly downward, not radially toward a center 2. Earth's surface geometry is Euclidean at all measured scales 3. Hydrostatic equilibrium produces horizontal planes, not curved surfaces 4. Classical fluid mechanics is exact, not approximate 5. Engineering practices are correct in assuming level surfaces. These aren't radical reinterpretations. They're straightforward readings of what water demonstrates. Conclusion: trust the water. Water finds level. This simple observation, repeated across every scale and location, reveals fundamental truth about Earth's geometry. The 31-mile salt pan is level, number 49-meter bulge. Lake Superior is level, number 4-mile mountain. The Suez Canal is level, no 1,600-foot elevation difference. Drainage basins are concave, not draped over convex spheres. All of this makes sense if Earth's surface is a plane with uniform, parallel gravity pulling downward. None of it makes sense on a sphere with radial gravity, unless we invoke unmeasurable curvature, instruments that mysteriously follow curves, and redefinitions of what level means. Water doesn't lie. It shows us reality directly, and reality is level. In the next chapter, we'll examine why the ground beneath our feet feels stable and stationary. If Earth rotates at tremendous speeds, why don't we experience the effects that physics predicts for rotating reference frames? The answer reveals something profound about the nature of our reference frame. We stand on an inertial plane, and water proves it.